we're going to take a look at some Pythagorean theorem word problems, thus the title Triangles in the Real World. Because what we've been doing is just looking at random triangles, random sets of side lengths, and being asked to figure out things about them. But now we've actually got context to these problems. And there's three main contexts that we're going to look at, thus the three examples. So you can expect to see 3 word problems on the test next week, one of each of these types of questions. All right. So example 1, can I get a volunteer to read this out for everyone real quick? Go ahead, Darius.
A building that is 12 feet high has a 15-foot ladder leaning against it. How far is the base of the ladder from the base of the shed? Number 1, draw a picture. Number 2, label it. Number 3, write the equation. Number 4, solve.
Perfect. Thank you very much. So we got a building that's 12 feet high, has a 15-foot ladder leaning against it. We got to figure out how far is the base of the ladder from the base of the, I know it says shed, it should say building, whatever, you know it's the same thing. So I got 2 numbers here. What are my 2 numbers in this problem? 12 and 15. I've got a 12-foot high building and a 15-foot ladder leaning against it. The first thing we need to do is draw a picture. So I'm going to draw a building here. There's my building. It is 15 feet high. Oops, I'm sorry, 12 feet high. Yep, you got me. It's a 12. It's an ugly 12, but it's a 12. Matter of fact, let's try that again. There's my 12-foot high building. I'm going to lean a 15-foot ladder up against it. So it's going to look like this. Doesn't have to be perfect. I know it's not a whole lot of space in there, but just try your best to fit that in. I'll say it again. There is going to be a problem that's worded almost exactly like this on the test. So when you look at it and it says on the test, oh, draw a picture, and you go, I don't know how to even do that. Just look at this paper. All right? Now, the measurements they give you might be different, but this is how we set it up. The building is 12 feet tall. The ladder is 15 feet long. What we're looking for is this measurement. How far is the base of the building from the base of the ladder? Because we're talking about the base, let's call that side B. Hopefully you can see that right triangle in there. And we're just going to use the Pythagorean theorem to solve. Which of these 3 sides is my hypotenuse? Is it the base, is it the building, or is it the ladder?
The ladder.
The ladder, of course. How can we tell the ladder is my hypotenuse? Directly across from my right angle. That's right. So we drew the picture. We labeled it with our numbers. Let's write an equation. Does anyone want to help me write this equation real quick? Anyone want to take a shot at it? Aline, go for it. I believe in you. 12 squared. Good. Good. Perfect. There you go. 12 squared plus b squared equals 15 squared. The legs of my triangle are 12 and my unknown side. My hypotenuse is the ladder, which is 15 feet long. Now what are we going to solve for? We've got to solve for the b. This is what we just did with the missing leg notes a couple days ago. So let's solve it out. 12 squared gives me 144. What is 15 squared? 225. Good. What do I want to do from here? Subtract what?
225 or 144.
We're going to subtract 144 over to the right-hand side. What happens to my 144s on the left? Cross them out. I'm left with b squared equals 81. Nice. Quick math. 81. How can I get b all by itself now? Taking the square root. I'm going to take the square root of the left, the square root of the right. And I'm left with b equals what? 9. There you go. I appreciate you saying that. 9 feet. Anytime, no matter what unit we're in, if we're doing word problems, we have to have units on our answer. B is equal to 9 feet. So what is 9 feet in this problem? The B, good. Is it the length of the ladder? Is it the height of the building? It's the base? Yeah. It's the distance between the base of the building and the base of the ladder. Right? 12 feet high is the building, 15 feet long is the ladder, 9 feet in between both bases. Right? So that's what we get. Now, you might also have this same kind of problem, but it says, oh, the building's 12 feet high, the bases are 9 feet apart, how long is the ladder? Okay, so you got to know what to plug in where, and you'll see that on worksheet 63 today, okay? What questions can I answer about that ladder problem? Quick show of thumbs, how are we feeling about that? Does that make sense? Kind of okay. Thumb sideways, what questions can I answer? If anything doesn't make sense about that, something's like weird. Yeah. How do you know what to draw? Good question. So, if we're starting from scratch, right? Let's say I didn't have this. The first piece of info we have is a building is 12 feet high. Okay, I know what a building looks like. And that information tells me that its height is 12 feet. Right? The next piece of info we have is there's a 15-foot ladder leaning against it. So if you're here on the ground, and you want to get up on top of the building, you've got to lean a ladder up against it like that. Bless you. Right, here's my little ladder. And that ladder is 15 feet long. So we got two distances. Now we're asked how far is, here's the base of the building. Here's the base of the ladder. And we're looking for this distance right there. Because the building is flush or flat on the ground, that makes a nice right angle. And we have that right triangle in there. Does that kind of make sense? If you drew it like this right here, you'll be fine because you can use your notes on the test and it's asking pretty much the same thing. So don't worry too much about what to draw. Just replicate this drawing. There's 3 heights. There's a building height, a ladder height, and a base height. Okay? This next one's going to be a lot easier to draw. So let's take a look at example 2. Can I get a volunteer to read out example 2 for everybody? Go ahead, Hope.
The square box is 20 inches wide. Find the diagonal length of the box removed from the front. Draw a picture, label it, write any place of its
Perfect. What type of shape are we going to draw here? A square. Everyone know how to draw a square? Good. Go ahead and draw a square for me. There's a nice square. What's that? Well, we know exactly how big it is. It's 20 inches wide. 20 inches wide. So my width on the bottom is going to be 20. Now, I'm a little stuck here. That's the only number I have. And the other problem, I had two numbers. Anyone know what the height of this box would be? 20? Why do you say 20? Because it's a square. All four sides of a square are the same length. So if we're given only one number, 20 inches, but we're also given that it's a square, we know that the height is 20 and the width is 20. But what are we trying to find?
Like how?
The diagonal length. What is a diagonal?
Just like if it's like.
Exactly, a slanted line. It's cutting through. So let's draw a diagonal line through this box. And what letter can we call that diagonal line? B? D? Think about the Pythagorean theorem. What letter we want to call that?
C.
C. Because it is right across from our right angle in the square. Everyone comfortable with how we drew that picture? Yes? Okay. This is one of those things where we have to know that a square has all the same length sides. Hopefully we know that. If not, we do now. So we drew the picture, we labeled it. Who can help me write an equation for this? What's our Pythagorean theorem going to be? Go for it. Yeah, go ahead.
20 squared
Perfect.
plus 20 squared
Perfect.
equals c squared.
There we go. So now we're not having a missing leg like in example 1. We have a missing hypotenuse. So our setup is slightly different. Up above, we were missing a B. Down here, we're missing our C. So we're combining two lessons together here a little bit. Missing hypotenuse versus missing leg. What is 20 squared?
400.
400. Perfect. So I got two of those. What is 400 plus 400? 800. So I got 800 equals c squared. What do I do now? Square root both sides. That's right. Nothing to subtract here because we combined our like terms on the left. Now let's do a little factor tree for 800. What two numbers would multiply to give me 800? 10 and 80, good. 8 and 100, another good one. Let's make this a little easier on ourselves, okay? We just added 400 and 400, right? What type of number is 400? Starts with a P. Definitely not prime. Pythagorean theorem starts with a P. Perfect square, that's right. 400 is a perfect square. So if I break 800 into 400 times 2, I can break 400 into 20 times 20. This is going to save me a lot of time, a lot of messy work. If we have a big number like 800 and we break it down to its full prime factors, that's a lot of work. That's a lot of mess. Now if that's a little confusing, let me show you what I mean. We said, we can do 8 times 100, right? 100 is 10 times 10. 10 is 5 times 2. 10 is 5 times 2. 8 is 2 times 4. 4 is 2 times 2. Okay, so now I've got a 2, 2, 2, 5, 2, 5, 2. It's a lot. It's a lot to take into account. Right? Got 2 times 2 times 2 times 2 times 2 times 5 times 5. Got a pair of 2s, and a pair of 5s. What's 2 times 2 times 5? 20. So we save ourselves all this work by breaking it up like this, because what we have now is the square root of 20 times 20 times 2. Is there a pair in here I can circle up? A pair of 20s comes out. And what is C equal to here? 20 root 2 inches. There we go. This is a pattern with squares that if you start to recognize it, it makes your life a lot easier. So that's the square box, square TV type problem. Questions I could answer on that? Again, if you're asked on the test, oh, a square something is 30 units wide, it's also 30 units tall. Work it out just like this. This is why we have these notes. Last but not least, a much, much easier thing for us. Go ahead. Are we allowed to use notes on the what?
Fine.
On the final? Well, yeah, it's just a test. You can always use your notes. Yeah. I wouldn't spend this much time on notes if I didn't want you guys to use them. I mean, you might have teachers in the future that don't let you use notes. I know there's teachers, 8th grade math teachers here that don't let you use notes, but I don't see the point in that. I feel like, you know, your notes are your resources for a reason, so
Same thing.
you can use it. Can someone read out example 3? Go ahead, Ida. Perfect. So this is what we did on worksheet 61, which you reviewed yesterday in Google Classroom. So we're given 3 side lengths. We're given 8 inches, 11 inches, and 14 inches. Which of those 3 side lengths is my hypotenuse? 14. Why do you say 14? Because what? There you go. It's the biggest number. So I've got 8, 11, and 14. My largest number always needs to be my C. We can call the other 2 numbers A and B. So 8 squared plus 11 squared equals 14 squared. With the converse of the Pythagorean theorem, we're looking for either a true statement, bless you, or a false statement. So let's solve this out and see what we get. What is 8 squared?
64.
What's 11 squared? And what's 14 squared? 196. Great job. Okay. We're going to add the left side together. What do we get when we add those 2 numbers? 185. Is 185 equal to 196? No. So, even though this poster does form a triangle, it does not form a right triangle. The question being asked is, does this poster form a right triangle? The answer to that question would be, of course, no. All right? That one's not bad, right? That's just the same as our other converse Pythagorean theorem problems. All right.